welcome to my class on electromagnetic theory. Today we are going to derive the fourth Maxwell's equation. Del cross H is equal to J plus dou D by dou T, where H is the magnetic field vector and J is the current density and D is the electric displacement. For that, we consider Ampere's circuital law. That is, Ampere's circuital law states that surface integral, line integral of B dot dl is equal to mu 0 times the current enclosed in the circuit, that is mu 0 times I, or we can convert this in terms of magnetic field vector H, that is, this is equal to line integral of mu 0 times H dot dl is equal to mu 0 times I is the net current, which will be the integral of J dot ds, surface integral of J dot ds, where J is the current density. J is the current per unit area. So the current per unit area, that is the current density into a small area, integrating over the entire area gives the net current enclosed in the surface. That is, mu and mu cancel. That is, surface in line integral of H dot dl is equal to mu 0 and mu 0 cancels, that is equal to surface integral of J dot ds, surface integral of J dot ds. Applying Stokes theorem, here there is a line integral, so applying Stokes theorem on the left hand side, surface integral of, so line integral of H dot dl is equal to surface integral of del cross H ds. Substituting this on the left hand side, you will get del cross H, surface integral will be equal to surface integral of J dot ds. Removing the integral sign, del cross H is equal to J. From Ampere's circuital law, this was the deduction. But there is an inconsistency in this Ampere's circuital law, which was removed by James Clerk Maxwell. That is, if you take divergence of these left hands of this equation from the left hand side and right hand side, if you are taking the divergence, we'll see what will happen. Del dot of del cross H is equal to del dot J. Here, left hand side is the div of curl of a function. Div curl of any function is equal to 0 by vector calculus. That means, which implies that this is equal to 0 by vector calculus, which implies that right hand side is also equal to 0. That is, del dot J is equal to 0. That is, divergence of current density should be equal to 0. But this is true only for the steady state currents. We know that, we have seen that, we have come through the equation of continuity, which shows that del dot J equal to 0 is true only for steady currents, and for time varying currents del dot J is equal to minus dou rho by dou T. This is the continuity equation for time varying currents. So there is an inconsistency in Ampere's law, which was removed by Maxwell and which is known as the Maxwell's modification. The modification is like this. Maxwell modified Ampere's circuital law and he gave it like del cross H is equal to J plus JD, that is, he introduced a new term JD, which is a displacement current density. This is the current density, which is a conduction current density, and this one is the displacement current density JD. So the displacement current density, you will see what is this term.